Hello, in this video we'll do checkpoint 6.66. They want us to use the divergence theorem to calculate the flux of F over S, where S is the boundary of the box given, and F is that vector field that's x squared plus yz, comma, y minus z, comma, 2x plus 2y plus 2z. All right. The divergence theorem tells us that the flux of a vector field over a surface S is actually equal to the triple integral of the div of F dv over some solid B, where B is the solid that's enclosed by this surface S. So a few things to note: that S has to be closed, and S is the boundary of B, and B is a solid, S is enclosing it. In fact, because S is a closed surface, sometimes they write the flux integral with a circle around it. All right, so it looks like we are asked to look for the left-hand side, and the theorem tells us that we should be computing the right-hand side. So let's find the div of F. So the div is equal to the derivative of the first component with respect to x, that's 2x, plus the derivative of the second component with respect to y, which is 1, plus the derivative of the third component with respect to z, which is 2. It looks like the div is going to be 2x plus 3. All right, the boundary is actually, or not the boundary, but the solid itself is actually given here already. This box that is being closed by the surface. So if we would have done the flux integral, we would have done the 6 sides of the box. But instead of doing the 6 sides of the box, we're looking at the solid interior of it, well, including the cover. But it's going to be given by these limits. So I think we're all set. That our flux integral then should be equal to the triple integral over B of 2x plus 3 dv, and this would be equal to the integral of 2x plus 3, and we can do it in any order we want. If we do this with respect to x first, the x limits are going to go from 0 to 2. With respect to y next, the y limits are going to go from 1 to 4, and with respect to z, and that's going to go from 0 to 1. All right, let's integrate this. The innermost integral has an x in it, and y and z actually don't have an x in it, so maybe we can even set this up where we just integrate from 0 to 1 with respect to z, from 1 to 4 with respect to y, and this is the only one that has an x from 0 to 2, 2x plus 3 dx. Okay, so the last integral will be x squared. That would be 2 times x squared over 2. The 2's would cancel, and then we have 3x. We're integrating from 0 to 2, so 0 is going to disappear. And if we put 2 in there, we're going to get 4 plus 2 times 3 is 6, so that's 10. This is going to be 4 minus 1, and the first one is going to be 1 minus 0. Okay, so it looks like our integral here would be equal to 30. So had you done the flux integrals with the 6 surfaces, you would have had to do them separately, add them all up, and then you would eventually get 30. And compare that with applying the divergence theorem, where we took the div and then the triple integral, and we would get the same result. Okay, I hope that helps.